me get my live up so I can see if any of you beautiful people say something. But yes, I am here to refactor a very old script along with I'll show you my list of stuff today to do. And it's right here. So I'm going to I have a stereotube. Is anybody watching? Oh, hey, one person's watching. Hello. How are you? So my plan tonight, and it's late here already, but I had a cup of coffee at like 6, maybe 5:30. So now I'm a bit wired. It's 10 o'clock here. My to-do list is refactor the Astera Titan tube and get that. You'll see. it looks like friggin' spaghetti. I want to add Boolean options to the X4 bar and the JDC1 fixture. By Boolean options, I mean, like, you can't see it right now. But if I go 1 at full, it's maybe 2 at 1. Yeah. This fixture has a couple things that are only necessary. That's would make for an interesting fixture. Has some things that are really only usable. If you're up close, and that is like the light that's in here. I did something with my settings that made that weird. Okay, whatever I did, I need to undo. Clearly there was an optimization setting in here that made me see it through that plane. So let's go back a bit, and I'll do all these. I'll do all these settings with you, unless the beams are just acting really strong. What the heck? I've never seen this. It's like it's going through the beam. Let me just back up all the way. Okay, this is how I started the day. Okay, there we go. So there was some setting in here that made me see it. Oh, wow. It's still doing it. Alright, well, I'm going to have to figure that one out. This is how some of my streams have been going lately, is as soon as I start, things start acting up. So, I shouldn't have saved there. Let's bring up my file, see if we can do anything about this. So I want to do that. I have a optimization checklist for all these fixtures, where I want to go through and make sure all these are checked so that when I start duplicating out, I don't run into problems. All right, somebody cross your fingers for me. Let's see what I did wrong here. I don't think I did anything different. Maybe it's the generate overlap events. gonna try downloading my old file from Dropbox or from Google Drive. I don't think Google Drive would have it. I've never seen this where it goes, where it, I mean, obviously your mesh will always, is it the draw distance? Because I know I changed that. No. Maybe it, honestly, it may have did this before. I just never noticed. Maybe I'll address this another day. Let's get to my to-do list. Delete some stuff. Alright. So my first order of operation is bring in this Astera tube. And it's not gonna work. Reason it doesn't work right now is because I migrated all of these assets into a project that did not have the DMX plugin, and that was a mistake. Bring in my JDC. That should be good. I just wanted to show kind of this blueprint in my flow. So I'm gonna make the Astera tube like this. But for a basic fixture that doesn't have multi-instance, I always start by setting my fixture patch. That runs off the DMX that is in the component right here. Right here. Create a variable called fixture patch reference. First adapt it to this, and then you're going to use this adapted version for a couple different things. If you have multiple beam meshes in here, I like to create I basically drag every single beam mesh in, and then if I had multiple, and then I do a create or oh no, it's add under array. So you would drop all of these in here by duplicating this a bunch and make a function that adds all your beam meshes. I would add that to right here after on fixture patch received, because this is going to have to run in editor. And if you put it right here, it's going to run during play mode only. So you'll find that when you're doing your programming or trying to build this, if you use that beam mesh, it's not going to have any beam meshes in it because it's that. And then in addition, at the start of adding all those beam meshes, before all these adds, then you would want to take that same array and do an array clear, and then you would link in that array. Kind of like this. Where is it? like on my X420. I'll just show you. This is not the event graph. My create beam array looks like this. So I have an array, and you can do this just by dragging out if you want to make sure you get the right thing. Dragging out, promoting it to a variable, and then on that variable, then you click this little drop down and change it to an array. But I'm not going to be using this, and I don't know what this is. Can I delete it? Yeah, okay. So let's get to business on let me just walk you through this next part. So get my fixture patch, build a beam array if necessary, and then get my normalized attribute values. Don't do the, unless you need to, don't do the just get attribute values. Because everything's going to come out as a as an integer 0 to 255, and these come out float values 0 to 1, which is much easier to work with. So you do that, you get all of your attributes. I like to store some of them to variables, especially because if you store them as variables, what I found is after you disconnect DMX and even shut the program off, as long as you save, when you turn it back on, it'll load at your last scene, which is nice to have. And then I just go through and start doing what I need to do. So set vector parameter value, set, so this is the material of the head. So here I'm modifying vector parameter value variables on this material, like JDC plate. Scalar variables. So this is for the center beam. Vector parameter values on materials again, but this time it's for the beam mesh. And so the beam mesh has a variable in it that I uniquely name each time called color. So that modifies that. Then I set the light color, and then I set the rotation of the fixture. All that said, this is the spaghetti from my first fixture ever. It's so spaghetti it causes my frame rate to drop. Just by looking at the graph. And so I don't know what the heck I did here. I know what I'm gonna do, and it's not this. So I think I had to delete some stuff because errors were showing up. But basically I handled each cell individually. And then I averaged and did 2 lights. 2-point lights instead of 1. So I'm gonna just completely redo this, because there's a lot of things that I would do very differently in here. First thing I'm gonna do, and I like to copy this one, is set my fixture patch. I honestly don't know how I don't have that in here. Like, where am I getting my DMX from? Oh, right. So this didn't have DMX, the DMX plugin. So there's nothing DMX related in here right now. But this is a good, what I'm about to show you is a good kind of footing for building a basic fixture. I think I will add a beam mesh in here, but at the end. Let's disconnect this and then drop in what we pasted from, or what we copied from the other graph. Now if you copy these in, just know that you have to create new variables or use variables that are in here. And so like DMX, that's bad because it's from an old blueprint, so we need to add a DMX component. And then bring that to our set fixture patch. For our fixture patch reference, we need to create a variable and expose it so that we can set it. And then do that. I'm gonna remove my Astera tube from here because I found that it could cause it to crash. So we have our fixture patch set. Next we need to build an on patch fixture received. And so we do that through right here. And by the way, if you're planning on making a moving light, I have a different method. It's a lot less home brewed, hand rolled than this method here. And so here I'm going from my end and trying to meet Unreal Engine, and if I'm making a moving light, I use Unreal Engine's method and sort of work backwards towards my own custom ability, but I try to stay within their system. So we have our on fixture patch received. We're going to get our attribute values next. So that's what these find nodes were connected to. So we're going to say get normalized, if I could spell, attributes values. And then you want to split this pin, which I don't know why they don't have that split as it is, but and then we drag this out. Yeah, we can still connect to these, but they're different. And since this is a multi-instance fixture, actually, let's look at our patch for this, if I even have it. I don't believe I do, but that's okay. I get to build a new one. So DMX library. I'll call this Astera library. I did learn that you can use multiple libraries in one show. So fixture types, add fixture type. Add mode, this is going to be extended. I think, yeah, there's 16 cells in an Astera tube. So we actually can't do that. We need to enable fixture matrix and then have 16x cells. That's all there is in a Titan tube. So we can say add cell attributes and then make one green and one blue. Save that, and then let's patch in one. I'm gonna do that on like address 301. I think that address is open. Check my GrandMA. Yeah, that address is open. So save that. And then go back to our blueprint. And then we're actually going to do away with this and say get normal, still can't type, matrix cell values. And I found a way to do this from myself. That was something I did before and I stumbled across it again. So split the this so that I can access this cell coordinate X. And what was it? I think it's trying to remember where it was in here. That needs to be updated. Refactored. Nope, not there. It's in here. I think it was just it was like basically what it did is just got all of the cells that I'm working with and used that as our quantity. Get matrix cell. Get all matrix cells. I don't know exactly what these hold in them, except the proper quantity without having to do anything else. So then we can get this, and then use this to say, to pull out from this, say for each item in matrix cells, which in this case is going to be 16, do stuff. And then we don't even need to use this pin. So this is going to count up. Every time this pin fires, this is going to count from 0 to 15. So we have 16 cells. So I can run this into my cell coordinate X. And then what's next? Yeah, for every time this fires, 0, get all the normalized values per attribute. 1, get all these normalized values per attribute. What was my fourth one? I hope it wasn't dimmer. That doesn't make sense. Maybe it was white. I don't know. I don't know why I had 4 units per cell. But I need to copy 4 of these. So every time this fires, for each cell, I'm going to get all of my attributes, which is only 3. Red, green, blue. I should probably look at the Titan tube profile, actually, because I'm going off memory. It's in here somewhere. Where's the channel layout? No channel layout in here. Let me just look inside Granime. Maybe it was strobe. RGB 16 pixel single strobe is 63 channels. 63 divided by 3 is 21. 15.75. How do I get? Let me look in MA2. That's how I can. It's got to be in the manual. Oh, that's a light bulb. That's 16 times 4 is 64 channels. Alright. Quit. Why does it go to that? Back. Is that a star? Yeah, starled.com. I did not know they had this. Mounting accessories. Built-in battery, wire. RGB 16 pixel mode. So that's 64. RGB strobe. So I would think I would need this one. I don't know why they have that gap there. So yeah, this is going to be RGB. So we only need these three. After we get all of these 16 times, we will then create a vector for each one and then store that. So make vector 3, wire all these in, and then promote to a variable. Store that as cell output. And then we're going to create, or call it RGB output, that's right. And then we're also going to create an array of all of these to use for later. So again, I'm going to promote this to a variable and then change its type to an array. And it's going to think about that, because that's what it likes to do. Search incomplete. That's fine. And then pull out from here and say add to. And then before we do that, we would actually need to clear this, so that we're not adding infinite items to an array. And then the value that we add is this one. So now we have our output per cell and our array of all of those cells, RGB colors. We're going to, I think next we just set our vector parameter value. And before I thought that I had to name each of these individually. It turns out it's easier. Where's my material? I guess I lost my material. When you're updating the material in the body, I named that. So screen, I'm gonna rename this to Astera body. Oh, that's not right then. Do I have to remake that material? I kind of don't want to. Be a lot cooler if I didn't. I think that is what I have to do. Now luckily I have my texture already made and my body and that's already mapped. I just wonder, can I? Yeah, it's It's not there. Alright, so I gotta remake a material today. That's alright. That's just more to cover and more to refactor. So I am going to name that pixel no space and then number. And how I do that is I already have my number right here. So all I need to do is do an append node or append string. And so this serves as a number, and then I just have to type pixel right here, because that's what I'm going to name it. I really don't even need that. I could just name the parameters 1, but that might get confusing to people, and myself included. So now that I have this, I can pull this over and use it. It takes a name, not that, so it won't come up, but it is set vector value on materials. And I think it's time to delete all this. I don't think we need it as reference. Alright, our target is our body, where the material will be eventually. And then the parameter value that we send is our RGB output. And we can make this cleaner by dragging this variable directly in. And then our parameter name is that pixel 1 through 16. So now we set all of these. Let's go make this material real quick, just so that both of us know where I am. Static mesh is the stereotube. It should populate materials on here. Yep, there we go. Yeah, what's this? Oh, I need to plug in my DMX here. Alright, that's fixed. Let's go over to our material. We only have one or two materials, right? Why do I have 3? I guess one was for the little screen. That's kind of inefficient. I would assume this would be our body. Oh, this was actually then our screen then. So let's go. I don't know why I made a unique material for the screen, but we're gonna make a new material. Body, and then the most important thing here is we hold 3 and then promote this to a variable. That's 3 and then click, and then I'm going to call this pixel 1, actually pixel 0, so that I don't have to add to it. And so this RGB value will be controlled by our blueprint. So we would just wire this into emissive color, but we need to add it to all the other ones. And then we also, yeah, we need to multiply it by the pixel. Otherwise it's going to affect the entire thing. So let's bring this in. And then this gets multiplied by I wonder if I can just do one of these. Yeah, I think I can. Yeah, let's try with just one value to make it more efficient. So then if I run this into my emissive color, oh. Yeah, that should work. So then we take this. Is that all we need? It is, but then I need to offset the other ones. So that's all we need for now. And then I'm wondering if I could make a material instance for this. So I don't have to load in this texture so many times. Let's do that. Not material instance, that's the wrong word. Material function. So let's go create material function. And this is mf underscore get pixel color at a specific position. So we're actually going to copy these two in, and then I should rename this to indicate this for the Astera, because I should be doing this with my other fixtures actually. But this is why I like optimizing and refactoring, because you come up with new stuff and then you make more work for yourself. So I need a, what is it, function input. Yep, one of these, yeah. Yeah, because this is going to connect to my pixel variable. And then we need a scalar parameter for this, for our UV. So this is going to say add. And then texture, coordinate. And normally in my previous ones I would break this apart into a vector 2. But what I learned is you can just add a 2 here, and this is actually going to live outside the material function, but I'm just showing you. You can do a 2 here and then just add that to this. Because this is a vector pair or a scalar pair making a vector 2. And this is a scalar 2, or a vector 2 with both scalars. But this is actually going to go to a function input that's a vector scalar. No, it's not. It's a vector 2. And then that gets passed into this. And this is how we're going to offset our texture number. Then why was is it when I connect that? It doesn't show up. Okay, there we go. I was going to say, I'm not adding anything to it. So, we could delete this. And let's save this. Oh, and then our input vector 3 in gets wired to the multiply of this. And then we just output that. So let's go back to our material Astera body. Now we have our pixel 0, and then we can do a material function call. I guess I should have labeled these, that would help. I don't know how it knows that I want that material function, by the way. It's just magic. So if I run this RGB in, which I do want to flip these two, let's see if it took in here. Yep. This should reflect let's go to here and say that the input position, use preview, because I don't want this to be required. So yep, I should get that, and if I make this purple, that will be purple. I'm gonna do them all white though. And then for position, that we use this when we duplicate it again. And you see already this is looking a lot cleaner. Now note that if you duplicate this and I change the value, oh no, it doesn't. I thought it would change the name of the first one. So this is going to be pixel 1, and then it helps to set this to a color. Excuse me. And now we'll go to our, promote this to a parameter for now. Promote this to a parameter. Oh no, as soon as I promote it to a parameter, it does that. Well then, let's just make a float, or make a vector out of these two, and then go from there. So our goal weird. Oh, because I'm not connected. I'm not doing anything. Alright, that's why that's so far off. Let's go back home. And actually that was pretty close what I had there. So I would think I would need to move the X, yeah. That stinks. Let's go back in here. And I guess this needs to be a subtract node, because I don't want to add in a whole bunch of negative numbers. go to the other corner. If I'm not subtracting or adding things, like, yeah, I'm using subtract. Alright, well, if this is going to give me problems, then I will just use negative numbers. Yeah, because I can't explain why why it would even change the position if I'm not selecting any, if these don't have any value. 1 minus 0 is still 1. That's alright. I digress. So all we're trying to do right now is find the distance between these. So let's say negative 0.1, negative 0.08, negative 0.06, negative 0.059, 0.058. That looks close. All right. Negative 0.058. You can do the math through numbers in here, but due to performance, I like to just do the math manually when we're setting our pixel position. So let's just hold 1 and make this value, and then go negative 0.058. And then we offset this pixel I guess we need a vector 2 to do that. Or, better yet, because I don't want to needlessly add those numbers, so I'm trying to think of a way. I mean, we could just go, just do the old school way. Isn't there a break vector? No, I guess that changed. Which they are float 2. And then we just add to this. And then pass that on. Well, yeah, our green stays untouched. We're going to make a vector make float 2. And then pass our green value straight, or pass our y value straight in. And then this will get added. Wait a second. I did this a little wrong. We don't need to delete this, but we need to change it to a single scalar. And then add a value of 0 to our preview. And then this gets added to, this number that we're passing in gets added to the x value of our texture coordinates so that we can offset it. We remake that, and then when we go to our stair body, It said that was a vector 3 it was still expecting, so I didn't like that. Now we just need a single value here. This, yeah, that's a single value. So negative 0.058. And then this gets added to this. There we go. We have our first two cells. I could add this add node into here, but I'm not going to. It's basically the same processing. And then, so then from there, we just keep adding these in. And then I broke out the calendar for a second. That's unneeded because you can just hit ×2 and it'll do the math for you. And then add this, and this is the last time we'll do an incremental change here before we hit all other pixels. So that's 5 pixels, 6, 7, 8, 9, 10, 11, 12, 13, excuse me, 14, 15, 16. All 16 of our pixels. And then just go ×3. Oh man. ×4. ×5. ×6. ×7. Negative 0.058 ×8. I'm going to make a typo here eventually. ×9. 0.058 ×10. I could have done that one in my head. ×11. 0.058 ×12. ×13. 14. 15. And then we name all of our pixels. Pixel 5, 6, 7, 8. I had a golden opportunity to not type there and I messed it up. Okay, I redeemed myself. And here. Time saver. So optimized. So if we add all these together, it should give us our total output. And this goes to emissive. We're missing 2. Did I do my math wrong? That'll be 1, 2, 3, 4, 5, 6. Pixel 7. Ah, that explains it. This needs to be a negative. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. So probably label this pixel 8. That needs to be a negative. And that's it. So we can save this. We have remade our material. We don't need any base color or anything, but I might make the base color a little darker. And so now that we can address all of our pixels from our blueprint, by passing in our parameter name and value, we can now move on to cooler stuff like setting the light intensity. So for that, we use our RGB array. We're going to get it, and there is a, before I did this math manually, I added up every single value and then averaged them together. Now, in the other blueprint, I had 2 lights per fixture. I don't think I like that. It's pretty, but it's not very optimized friendly. So I am just going to go down to 1, because if you have 10 Titan tubes, you now have 20 point lights in a scene, and that's already going to cause chaos. This stuff is hard enough on your GPU as it is. So there is a node though that averages, and you just have to pull away from a vector or from an array and then type average. And it, I'm sure if I went into here, it would say, you know, adds up all those and then divides it by the number in the array. So we can use this to set the intensity of our point light. Or sorry, set the color. Set custom light. Why do all these nodes look different? Yeah, set light color, point light 1. Well, let's break apart these two. Wire them in. Make sure this value is at 1. And now we have our light. And then I'm going to do one new thing. I got rid of the beam mesh. Or I got rid of one point light, but I am going to add a beam mesh to this. So we can do that by going window, viewport. And this doesn't have our body texture yet. So, stair body. Which that's about what it should look like. Right, and then we need to add a component called, well, first let's look at this. It's similar to this, except it's kind of 4-point lights. Let's just go to engine, content. Maybe it's not in here. Engines, no. Plugins. Yeah, that's why I look for it in content sometimes. Because to me, it is content. So our DMX fixtures content. matrix beam, that's what it's called, I forgot. Matrix beam is a very small material for something. Now what I don't know is what the mesh is for this. It might be the beam mesh, the normal beam mesh. Let's try it real quick. So I'm going to copy this. So I don't want to modify my engine content or run any risk of that. And you know what? Speaking of that, I should be able to find it in here. Yeah, static mesh beam. I don't see any kind of like matrix mesh. So let's see what happens when we use our let's see what happens when we use our normal beam. So if we were to put our beam mesh on here, it would look like one of the beams that we did. Apparently that value is dead. I did this with a Nexus 2x2 panel. Is it going to apply to a plane? Yeah, it does. Which brings about another mystery. Let me check on something real quick. I do want to have a fresh copy of that beam mesh material in here. Masters, yeah, MB master. I want a fresh copy of this. And then, yeah, I should be able to apply this material to it. Yeah, there we go. So that works like that, and I guess this just works with a plane. Which means that that plane has to follow the camera. But we could make it billboard, because if we have this plane here, like the other one was 3D, but if we have this plane here and then we look at it from this angle, it's going to look wrong. There's a function called billboard in, pretty sure it's in Unreal Engine, that should be able to help with this. So let's go back to our blueprint. And then we have to add a plane. And given that it's a plane, I actually might make a couple of them, but let's just do one for now. It's actually going to look like this. And then I want to leave this up for now. What's wrong? Oh, set light color. Yeah, I should give this the point light. Alright, back to viewport. Is there a billboard option in here? No. I might have to just do it manually. I mean, luckily I think it's pretty cheap to run. Yeah. have to do it in here. And which we shouldn't put it on the event tick, we should put it on this on fixture patch, because it's going to get fired in editor. So let's grab our plane, which is serving as our beam mesh, and then we'll say I feel like we need to if we use the third person character as our end target, you know what I can do differently? Here, let's do this cheaper. Just make 2 of them. Kind of like a video game tree. Like if you've seen this, where you get close to the bush and you realize it's just a couple planes with an opacity texture. That's what this is. And so now if we view it this way, it would honestly look, that should look right. And now we don't have to follow the camera or anything. So that's done. And then both of the, I'm going to make a, well, I can pull from the copied on engine content for now. Let's copy, what are we doing? No. I like to copy this reference. And then I should just be able to paste it in here. No. So let's type in matrix. Yep, copy engine content. And same with this. Okay, now I'm not seeing it on one of these. That's because it turned 90 degrees somehow. There we go, that's my goal. And so you can only see it from one way right now, and this is where if I make any more changes to this copied engine content, I'll make a Astera specific one. But in this one, and so this is what we need to move over. So let's find this asset. Yeah, plugins. Copy this, and then we can modify this. And I actually find using material instances kind of messes. It doesn't work very well with what we're trying to do. It seems to like forget. It's like it seems to fail to update sometimes. So I'm going to remove this reference from both planes. And then, yeah, that's right. Modify our matrix, delete this. Then modify our matrix being master. And all we have to do, we did say it's a two-sided texture. That's not good. Don't make me do this inefficiently. Alright, well, still more efficient than following the camera around. going to take both of these and actually copy them again. And turn it 180 degrees so that I have planes facing opposite directions. And now I can see this from any angle. And it's cheap. It doesn't use volumetric light. And so now I need to modify the parameters inside this, which is pretty easy. All I need to do is say drag out from one of these. They say set vector parameter value on materials, which we did back here, but this time it's for the beam planes, so to speak. Okay, so we got all four of these. And then the value that we're setting is our where was it? It's this one. I don't know which is cheaper, so I'm going to do the one that looks cleaner. So I don't know if this is cheaper than splitting the structure pin here, but yeah, this is what's happening. And then I need to drag in my other 3 beam planes. And set those as well. And you can set multiple things with this. That looks good to me. Let's compile, save, make sure our proper variables are exposed, and then we'll do a test. So drag in our stair tube. Doesn't look bad. Where is that shadow coming from? Is it coming from itself? No. It's probably just a little bit of directional light that we have. But that looks pretty okay. It's hard to tell that that I'm just using planes here, even if you look from above. It looks like fog. I think what I want to do though is let's parent these 3 to this one, and then scale this one up a bit. There we go. And then by extending past it, it kind of gives the illusion that it's a tube. Ooh, wow, that worked. It's clipping a little bit on the edge here, so let me cut that in half. And we'll call it at that. There. That looks fine to me. If you look really close, you can still see the clip. Let's test this. I have a Titan tube patched at nothing at all. Oh, and then I need to modify my asset here to have an additional cell attribute that does nothing. Which is kind of counterintuitive because in the MA fixture, if you want to tighten tube, 64. Here's some 64 ones. I was going to say in the fixture library on Grand MA, it shows it as 63 channels. So currently finding a profile. Stand by. I'm gonna go with the RGBW 16 pixel mode, just because it evens out to 64 channels. We could actually get a white cell in here in a second, but I want to do other things first. Fixture 301, and then I said this was address 301. Save. Then in here, set my fixture patch reference. I can delete all these. Cell coordinate I don't need. This I don't need. Light intensity though I want. So let's hook this up to this so that I can have it during runtime, and then all I'm gonna do is push this to my point light and say set intensity. And light intensity, this is going to be like 100, which might be a bit bright. And then in addition to wiring this up, I'm also going to go to, I forget where. My light changes attenuation radius because this is huge. And a stereotube does not light things up from that far away. So we can lower this to like 400, maybe even 300, and that does better. Even probably 200. That should be more performant. Let's give it a test. Fixture patch reference, go to our stereo library, stereotype tube 1. And then what I like to do, or the only way I know how to do it, if you make your own fixture in here, it's kind of harder to do this. Should I say it's harder for Unreal Engine to do this? You go to your patch tool, and this won't actually patch your fixture, but what it will do is allow you to, if you set it to the right thing, allow you to receive DMX in the editor. Which it looks like I'm not really getting, but I think because I don't seem to be getting those channels. Patch. Yep, this is fixture 30 or universe 1 address 301. Ah, there they are. Yep, 301 through 233. So my dimmer is off. My green is at max and blue is at max. So it doesn't look like it's receiving an editor. Let's go figure out what's going on. First thing I'm gonna do, well, just jog my wheel. I don't see anything in here. Do a print string. No DM. Oh, there we go. So we are receiving it. We are able to set our light. This very high impedance air gap. That should be good for the rest of it. There we go. So I'm getting connection. My point light's at the bottom. That needs to be fixed. Although it kind of looked cool. Okay. Oh, that doesn't make sense. Let's raise up this brightness a bit. So, for some reason, we're not sending our color. It's only going to our point light. It's not going to our materials. Did it dump that? Body. I don't know why all the materials are different here. Yeah, that's what it should look like. So let's set our fixture patch again. Patch tool. Okay. Oh, so once again, it's not sending to the materials this time, and it looks like the light. Yeah. It's just not sending to the plain mesh material. So let's go in here and find out why. Because I didn't give it a name here. What is its name? Well, it's simpler than the other one. Where are you? I'm looking for a vector 3 parameter. I guess we have to make our own. I would have assumed it was in here. Why is this a thing? Alright, well, we get to modify this material a bit. Well, it's got to be this one then. Matrix data. Parameter. What? Now let's just try multiplying this with a vector3 parameter called matrix color. And I should stick to my old naming convention of caps locks for these. Okay, now we can communicate with this parameter here, which it did. And somehow we lost our material again on our static mesh. How? I don't. Yeah, it keeps going to this. I want to see when it does it, but let's just add in a new one and see what happens. That's correct. Actually, oh, that's why. Give this a default value so things show up. Go out. Now we have something default. I think we're gonna get rid of that other texture. Let's increase our light intensity. I don't see our light actually. I don't know what happened here to our light. Set light color, point light. Maybe it's because nothing's patched yet. Something's glitchy and I don't know what. Like, y'all saw my point light. There's my point light, but as soon as I move this, my point light disappears. Why? Let's find out. I don't know where to actually begin assessing this one out. So I will use ChatGPT for hopeful guidance. Do I have any construction scripts? Aha, that's why. See, sometimes just typing things helps. So construction scripts are executed in editor, and that was before I knew that you can wave this little magic wand and it dumped my textures again. But may be the last time that happens because I just removed that. Oh my gosh, it's so bright. Let me try something actually. Yeah, it does not modify the fixture patch reference. Okay. Yeah, our point light's there, it's just not very bright. There you go. I feel like the brightness of that point light blends in the mesh. And all I'm doing right here, by the way, is pressing my Grandmaster down and back up, and it changes the DMX values just for a moment to fire off this pin, which sets everything else. So let's see, what was making it lose its meshes before? Was it just changes in this? Okay, it did do it again. This one is a mystery. I've never seen this one before. Are they saved in the blueprint? Yeah, a stair body. Is this a very simple? Yeah, cool. Complicated. So yeah, they're saved in here. Let's see what ChatGPT said. Yeah, I don't have any of that. I deleted it. Oh, I could delete all this. Why is this light so bright as well? Oh, maybe I should lower the intensity on here. try to is if it's, what are the default? Yeah, there it is. So let's try to change these defaults to, I double clicked on the mesh, like in the asset window. So stair body, chrome, and black background. Now I should be able to save this and it's not going to revert anymore. Let's just add any old node to give it a change. Probably hook it to the event pin and make it more meaningful. And then, there we go. Learn something new every day. So now we should be able to, once again, change our fixture patch ref. Then waiver fairy wand. Change DMX values. And now it's blue. And then we can, I yet to figure out how to address that line in the middle. I'm almost wondering if my sizes are too big, but I find when they overlap it causes more problems than this, because this, you get 3 feet away, you don't notice. But yeah, you get in close. I guess I'll try to fix that in the future. And so what I want to do is say fixture, what? Oh no. 301.1 at full? Yeah, there we go. Then I can highlight and next to the rest of these. Oh, that's weird. Why does only the last one come up? So you mean if I went 301.1, 301.16, let's just do 301 at full. Why did it take so long? What the? But yet if I change the dimmer value, no. Oh, I have highlight on, duh. I thought my DMX here froze. Alright, so if I go red, and then add another phaser step, go to blue. You know what, in the spirit of Christmas, let's go to green. Yeah, it'll do that. Then can I change the offset on it? I don't see it doing what it needs to do, really. What I did last time was I had to select all these fixtures from the fixture window. There, now I see some lines, and I can go to phaser overall. Probably do 0 360. There we go. So yeah, it's not quite averaging them together, it's just going with the first pixel. Let's get to the bottom of that. Doing the light too? Yeah. Oh, I get it. For every instance of the fixture, I'm clearing the RGB array and then adding a new one. So I need to move this to the beginning of here. That way it only fires once per DMX packet and not on all 16 frames. Okay, it's still flowing. I broke something, even though the blueprint works. Never came back. It's not showing me my DMX tools. Sounds like a reboot is in order. Yeah. Oh no, it actually used to do this. Oh, I gotta reboot. There we go. My fixture patch ref still saved. Yeah. So I just need to wave my magic wand. And now it receives. Yep, and now this is all averaged together. And I will say that light blending in with that fall off looks pretty darn realistic. So now I can there we go. I have my refactored Astera tube. I can switch to game view to see it in more of its beauty. So what I want to do now, before I leave this, is give the user some options on this. So, well, the first thing I want to do is try to make some of those options automated. So I like to be able to have them disable the beam mesh if they want. I'm trying to think of the best way to do that. Can I tie an event to a Boolean change? OGPT. This is something it would know. I don't want to use a tick. Yeah, this is what I want, a dispatcher. Let's try that. What does dispatcher mean? Event, dispatchers, create event. Event. Is it custom event? I mean, the word I'm looking for is bind event to Boolean, but that doesn't exist. You know, we can do this. It's off. If it's off the event tick, it still won't fire. What is the best way? We could do this because these are all probably going to be used with DMX. Does my quality look bad? Oh, because I'm on 360p viewing. Okay, cool. What I could do is just make some Booleans. So say does beam, let's say does it is too late for me to type. Pint light, I could use that. So if we're using the point light, then and only then, set up a branch here. And then we're going to set light color. If we're not using the point light, we're actually just going to take our point light and say hidden in game. Probably this one. Oh. Probably have to drag out from this. Hidden in game. Set hidden in game. Oh, context sensitive. There we go. So if we're using a point light, go ahead and set the point light. If not, we're going to set it to hidden in game and then resume with what we were doing. And this is how a lot of these processes are going to go. So likewise, make one. We could do something different with this actually. Well, no. Using haze. And we do have to have both of these exposed. And so, just like we did the other one, do a reroute node here, keep things cleaner. So just like the other one, if we're using haze, then we're going to set our vector parameter value. If we're not using haze, set it to hidden, just like that one. And then I might be able to just do this one, and they would all track forward. Because these three are parented to that one. And so I do want these default values to be at full or at true, but then not using haze. There we go. It disables all four. No, it doesn't. It only did to the one. So yeah, we got to do all four. Alright, and then after that, we resume with what we're doing, which is currently nothing. The other thing I want to do is have a float value in here for haze level. This is going to be a float, or avoid things freezing, make it an integer. No, let's make it a float. We'll be hopefully responsible. And so what we're going to do is multiply this by our haze level. So that if our haze level is set to half, this gets half the value. And this would kind of be similar to our light intensity. Light color, I'm going to have that in the standalone version, so I don't need that now. So now let's check back using haze. Oh, it doesn't come back, does it? haze defaulted to 0. Let's set it to 1. Cool. Oh, and then I need to expose that. Yeah, I did. Where is it? Haze level 0.5. There we go, it's half. If we go to like haze value 5, yeah, it's gonna be thick. So that's nice to have. I like this. Another optimization thing I want to do. So yeah, everything down here is kind of optimization related. Everything up here is just core functionality or things to look good. I think this is the most important, so we don't really need that, although we could be able to delete it. But if you don't want it, you don't want it. Let's do another branch. And this is where we choose if we update the body material or not. So true. And then if it's false, I want to say do this, but that's the same amount of processing. That might be more processing then. Just set it to dark. Let's just give them the option anyway. Alright, so now you can choose between updating your body material, updating the point light, or updating the haze levels. The next thing we're going to do is make it so you don't always have to use the point light method. We're going to do that by pulling away from here a little bit. And then we're going to do what's called a multi-sphere trace by channel or for objects? Probably for objects. This does use a bit of processing, but what it's going to save for half your Titan tubes if they're in the air. What I'm doing is basically if your Titan tube is, or your any object is far away from all the other objects, if too far to even put light on it, then it won't render the light at all. So we say both of these will go to it. And then we want to draw okay. Then yeah, we want to go by channel. There we go. So I think if we do 0, it will just do its own position. What the? Why did these lose their material? How did they lose their material? I mean, even when I bring a plane in. Maybe if I just bring in a new one. Which was I doing? Wave my magic wand. There we go. So I do see that line trace out there. So that is where it's checking for objects. And so it is finding objects. So let's say print string and get our true or false from this and do some research. Here true. If we lift it all the way up here, still true. If we lift it even further up, still true. What is it? What is it hitting? So this is going to contain all the things that it's hitting. Hopefully. Hit result structure. Somewhere in here it should be display name. Let me hit actor. It's hitting the floor. Floor 2. How is it hitting the floor? Oh, wait. Sorry. And what if I just said get location? No, just from yourself. I guess you can do static mode. Get world location. And then this is going to be the start and the end. Because I think this is sometimes for like gunshots. So you projectiles, you want to see if it hit anything. There, I don't think it's getting anything. And now it's getting something. So that's what I was going for. Now this should just read true or false. So right now it's true, and if I lift it up here, It's going to be false. Perfect. So what that says is this light hitting anything? In fact, we could even take this one step further and get the light's attenuation radius and then use that as our radius. So now it follows the light's attenuation radius anyway. So if we change the attenuation radius, yeah, we're good. So basically here it says, is this object, will it receive light anyway? And if it doesn't, I don't know if the software currently does this by itself. If it does, we're just wasting script here. But if it doesn't, then we'll go like this. Branch. And then if we're not using the light, just hide it. I would destroy it completely, but we might have a movable strip light. I can actually tell you we're going to eventually. Actor hidden in game. Hidden in game. So yeah. If it's true, if we are in range of something, set it to not hidden. And this is all optimization, so I want to keep it down here. And then turn off debug. And then, there we go. And now both of these can go back here. I'm going to do a reroute node here, keep things cleaner. Cool. And that is what I wanted to do with the Titan tube. That gives me kind of all of my performance options. What I want to do now, I'll bring up my handy dandy notepad, is go through an actual optimization checklist. And so number one, oh, not that, is collision disabled for everything. I can guarantee you we're not going to use the collision attributes on any of these meshes in here. So let's just go through and disable collision. Overlap, can character step up on. This is going to be no, because that uses collision. Collision presets, no collision. Okay, and then we're going to do that with everything in here. And so these, no collision. Okay. Next thing is we don't want these beam planes here generating shadows. So item 2 is beam shadows disabled. Let's just search shadow here, and yep, they do. We don't want that. Cast shadow. Cast shadow. And we don't want to receive CSM shaders or shadows. I don't know what a CSM shadow is, but our beam planes are light sources, so they have no business being a shadow. So I'm gonna make a note in this: disable CSM shadows. Okay. Next is volumetric light disabled for all lights in the light. And I mean actual lights like this. I will check those planes too because of nanite. Light shadows volumetric fog. So that would hopefully prevent it from even doing volumetric scattering. Let's look for that. Yeah, there's no way to disable that, so hopefully setting it to 0 changes that. We did add a sphere hit check to disable the lights. We added a haze intensity. I can't type. These things I'll do tomorrow. It's late here. This took a bit longer than anticipated, but I think it makes a good complete run of creating a DMX fixture with a little bit more bells and whistles than I showed you last time. So thank you for watching. I hope you got something. What is this? Why is there a line here? Let's check. This is going to be on the static mesh component. I think it's just an inconsistency in my UV mapping. That's kind of cool. So I think that's just something I need to fix in Blender. I know I didn't bake lighting with these, so I handmade the pixel. And so it might just be that my you know what, actually, that's a very easy fix. I just go into GIMP. Now, the other question is, Where can I find this? Source file. Oh wow. Users, Caleb, pictures, pixel 1. Let me find that. So this PC, users, Caleb, pictures. I probably moved it since then. Someone. Yeah, I did move it since then. Nice. I didn't really know I can export. So this is new. You can export a texture. In the past, what I've done is like screenshot this. Don't do that. You can right click, asset actions, export. Something happened to my pictures folder, by the way. That's why I can't find it. I'll just move it to downloads. Pixel 1. And then I think all we need to do, to be honest, during this time I used PowerPoint to make my textures. I know one person saw me create the JDC1 texture with PowerPoint. Alright, where's my downloads folder? You know what? I bet you I could just drag this straight in. There we go. So I'm willing to bet all I need to do is do a transform on this. And what an uneven texture too. Let's just scale this to like 1200. Oh no. There we go, that's what I wanted. And then do another transform to crop it back down. size, bring this back down to 975. Oh, that's cool. And there we go. So now that just stretches a little bit higher. We can overwrite this. Let's save it as something else. These are impossible to tell. Pixel 1, 2. Then move this. Back in and see what happens. No, that didn't work. Well, I'll test this out. I'm gonna sign off for now. But yeah, thank you for watching. Thank you to my viewer who stuck all the way through. I know it was painful at times, but I feel like there was a bit of decent information in this. Maybe that's why I added a point light on top and bottom. Well, I'm okay with it because we're never going to have an Astera tube buried beyond half in the ground. That's only a video game thing. I know we didn't turn on collision, but we're going to pretend like collision exists. So I'm going to log off. I think tomorrow I'm going to continue. I have some stuff going on, but I think we're going to continue with this checklist. And do this to the other fixtures, do this to the other fixtures. So basically all we did today was just this. No, that's kidding. We did all of this stuff. Oh, make the beam mesh non-clickable. ChatGPT, I have one more question for you. I've asked this before, so let's use better reasoning. In Unreal Engine 5, in Unreal Engine 5, is it possible to make a component in a blueprint non-clickable? Think. Set those collision properties. Trace settings. So it says, by adjusting collision and trace settings, you can make a component non-clickable so that the mouse clicks pass through it and interacts with objects behind it. This usually involves configuring the component's collision channels to ignore visibility or traces, setting it to no collision. We set it to no collision. In Unreal Engine, clickability, or the ability to select an object via mouse clicks, typically come from line traces that the engine performs against objects' collision. So let's try it then. No, I can definitely click on that. You know what I can do that's kind of doesn't really make sense, but it just might work. If we do on-clicked, and then do that for everything. Well, you know what? Yeah, let's just do that. On-clicked. Because the problem with these beam meshes and planes, especially like with a fixture like the JDC one, is when you click on it, you know, you've got, let's say these were much bigger or your camera was close. If you're trying to access items behind your haze, you'll keep clicking on this object. So I think I'm gonna do tie all these to one, and then say if you touch any of these, well, yeah, so just set all of them to not be visible for a bit. Or even, honestly, just that one. Just the one that you're talking to. Set hidden in game. So it's going to be hidden, and then we're going to delay for X amount of seconds. In fact, we can make this a variable that gets exposed, and we say this is click hide timer. We have a new thing. It's called a click hide timer. Its default is, I would say 10 seconds. Seems like a good number. So every time we click on one of these beam planes or a beam mesh, it's going to hide for 10 seconds and then unhide. So we can, it allows us to click on the thing behind it. In fact, we can make this a function. Why? How? When? Why? Delay cannot be placed in function graph. What? Alright, whatever. That's a weird rule. I'm sure there's a good reason for it that I don't understand, and that's why I trust Epic Games on these things. But it'd be a lot cooler if I could. This one is exciting because these beam planes, other beam meshes, have kind of driven me crazy sometimes when I'm building a lot of stuff. Why did I delete those? Alright, there we go. Now, oh, that only works. I guess that only works in play. could do though as well, we could have one thing in the construction script, and that is basically similar to this. Let's just cut this out and then go to construction script, and it'll probably shoot down our delays. Yep. But that's okay. Can I duplicate this? Nope. Well, I guess this is getting deleted. And so we're just going to have a Boolean here that says make, this is experimental here. Actually, no, I can trace this one. So what's going to happen is if I change this variable, I'm going to want to bring it to the top so it's easily accessible. Every time I click this, it's going to fire this construction script. If I do a print string right here, and then I change this variable, it's going to run that print string. And so I can have this Boolean trigger this thing and then check the state of the Boolean. So do branch here. And so as soon as I change this, this will go hello. And it says, well, did we hide the haze plane in editor or did we deselect it? And so if we selected it, then we're gonna just hide all of these. If we deselect it, we're gonna unhide them. And furthermore, if we get busy and then wonder where our haze went in game, we're going to do that at the start of runtime. So after we set our DMX patch, we get this and we ask ourselves, did we hide the haze during playing in editor? And if we did, then we get all of these. We get all of these for and we set hidden in game to false so that they show. We don't have to do the opposite because we hide things in runtime a different way. So we don't need to do anything if it's false. Let's try that. So of course now nothing's coming up. Hidden haze in editor. Uncheck that. Alright, cool. So we have our haze and we're trying to click on this cone behind it, because this cone needs our attention drastically, or else our project will demolish in a minute. But every time we try to click it, we click this. So now we go hide this. There we go. And then when we start our game again, it comes back. Sweet! We're solving problems. Problem. What does that go? Solve 'em probler. Cool. So I'm now going to solve the problem of me being tired and go to sleep. But this was kind of a fun day. I won't lie. Because now I have my Titan tube back. And I think I'm going to back up this project. So on another day, we're going to basically repeat everything we did here with the other fixtures. The only difference is these other fixtures are already organized. So that makes life a little easier. So thank you everybody for tuning in. Thanks to my Patreon subscribers. You guys are kind of fueling me to complete these things. And I want to get unlimited fixtures to all my Patreon subscribers, which is what I'm working towards right now. So yeah, follow me on Patreon if you aren't. I'll update my YouTube description to have my Patreon in case you guys can't find it, because I just realized it's probably not in there. Thank you everybody. Cheers. Have a good day. Have a very merry whatever you celebrate. If it's just it being a new year, then Happy New Year. Thanks everybody. Bye. Oh, where's my OBS? Oh, here it is. Later, y'all.